Welcome to today's Explainer. We are diving into a structured academic breakdown of a highly sophisticated machine learning system designed specifically for anti-money laundering, or AML. And I want to set our core thesis right out of the gate. In this space, computational power must support, but absolutely never replace, human responsibility. It's a fascinating dynamic, so let's just jump right in.
To keep things perfectly organized, here is our structural roadmap. We're going to hit four main pillars today. First, task analysis and the core AML problem itself. Second, user experience design. Third, privacy and data protection. And finally, ethics and algorithmic bias.
All right, Pillar 1, task analysis and the AML problem. Now, the whole issue really stems from the sheer, staggering complexity of modern banking. Think about it. Today, a single customer might simultaneously be juggling checking accounts, deposits, complex financial instruments, and even insurance policies. So imagine being a branch manager trying to manually hunt for anomalies among thousands of completely disconnected transactions. It's practically impossible. Looking at each transaction in isolation hides those sneaky, suspicious patterns that really only pop out when you view the entire portfolio at once. The cognitive workload for a human trying to do this manually is literally overwhelming. And because of that massive data overload, we arrive at the golden rule of this system. The technology is there to select, organize, and prioritize the data. It is never, ever there to replace human judgment. Under Italian legislation, for instance, it is strictly the human operators who hold the legal responsibility for assessing suspicions and submitting reports to the Financial Intelligence Unit. The machine learning model, it just does the heavy lifting to highlight the anomalies. Moving right along to Pillar 2, designing the user experience. How do we take all of that complex machine learning output and present it to an operator in a way that's actually safe and effective? Well, it comes down to a highly transparent sorting mechanism built into the dashboard. Through this dashboard, the system mathematically reconciles 100% of the analyzed transactions, both by sheer volume and monetary value, into three very distinct buckets: alert, further investigation, and regular. This is absolutely critical because it allows the user to immediately verify that no data, literally not a single cent or transaction, has been excluded from the analysis.
Now here's where it gets interesting. How the system handles uncertainty. That further investigation category, it explicitly communicates that the model just isn't sure. It proves a really vital concept, which is that missing or outdated information does not automatically equal suspicion. The system doesn't try to present its assessments as absolute certainties. Instead, it's totally transparent about its limitations.
So let's look at the operator's actual workflow to see how this plays out. An operator reviews an alert, checking out the risk score and the reasons behind it. They can then mark it as in progress, investigated, or excluded. But here is the kicker. If they mark an item as excluded, the system actively forces them to provide a justified reason. This creates a validated feedback loop. We can't just let the system learn indiscriminately from every single click, because human errors or biases could easily be automatically absorbed by the model over time.
Okay, let's shift gears to Pillar 3, privacy and data protection. Because we are dealing with highly confidential financial data here, the regulatory constraints are understandably massive. These rigorous safeguards have to be built in from the ground up. The system runs in a secure, bank-controlled cloud. Access requires multi-factor authentication and operates strictly on the least privilege principle, meaning users only see exactly what they need to see to do their jobs and nothing more. Everything is recorded in tamper-resistant logs for auditing. And of course, strict GDPR compliance is mandatory. In fact, because the system uses profiling techniques on such a massive volume of data, it requires a Data Protection Impact Assessment, or DPIA, to mitigate any privacy risks before it even gets off the ground. And that intense focus on protection naturally leads us into our final pillar, ethics and algorithmic bias. Using machine learning in AML is incredibly powerful, but it presents a huge ethical landmine. The real danger of transforming statistical correlations into absolute judgments about real, everyday people. The system has to carefully tiptoe around two major data risks. First, historical bias. If a bank heavily monitored certain categories of customers in the past, the training data is going to make those groups look artificially overrepresented as suspicious. Second, dataset imbalance. Let's be real, truly illicit transactions are a tiny fraction of overall banking activity. Because of this, the model has to be rigorously evaluated on how it handles both false positives and false negatives, not just its overall top-line accuracy. To combat what experts call automation bias, which is just our human tendency to blindly trust whatever the computer tells us, the system actually forces conscious human review. Before confirming a critical assessment, the operator must answer mandatory validation questions. For example, the system will explicitly ask, "Is there a reasonable economic explanation for this transaction?" It actively interrupts that automatic confirmation reflex. It demands accountability and fairness from the human operator.
To tie this all together, I want you to consider this core philosophy. The algorithm identifies what deserves attention. The person understands the context, evaluates the evidence, and makes the final decision. We are not delegating sensitive, life-altering decisions to AI. We're building a structured collaboration between the raw processing power of machine learning and the nuanced ethical responsibility of human oversight. Thank you so much for joining me to unpack this explainer today, but I'll leave you with this question to chew on. As these algorithms get smarter, how do we guarantee the human always stays firmly in the driver's seat? Keep questioning the tech, and I'll see you next time.